Hello everyone. In the last video we have seen the best case efficiency of quicksort algorithm. Today we'll discuss when the worst case efficiency will occur and the general plan of that one. Yes. So I'll just take some array. So this is the array I have taken. If I'll just take the first element as the pivot element, and then if I just divide the array, for example, the array will divide over here. Okay, means here only the array is just going to divide. After this we have all the higher numbers. So the left part of the array, this is left part of the array, this is right part of the array. Or one more possibility is, if the element or the pivot element divides the array exactly at the end element. So if this is the case, this is the right array and this is the left array. In both the things you can see, in first situation the left part of the array is empty. In the second situation the right part of the array is empty. If this is the case while solving the quicksort, then this will come under worst case efficiency. This comes under worst case efficiency. If any of the array is empty, either left or the right part of the array is empty, then that is considered as worst case. So how will be the general plan for this one? The first thing, it is as usual. If only one element is present, no need to sort, so that is equal to 0. Okay, here you can see how these are from 36 to 90. How many elements are there? N elements are there. And here, if left part of the array is 0 means, can I write it as T of n by 2? No, because array is not divided into 2 equal half. In the previous, it was 2 equal half. Both the side we have some elements, but here that is not the case. So this one will be T of 0 because I'll be not having any elements. And if I take out pivot element from n elements, yes, this is n, because n number of times I'll be getting a pivot element. How many elements will be left out? One is pivot element, means the other are n minus 1 elements. Is it not? So here what will be the general plan? One part of the array, either right or left, is 0 means it should be T of 0. In another part of array, how many elements will be there? N minus 1 elements will be there. I'll write it as T of n minus 1, and then n number of times I'm going to select the pivot element. I'll just take it as n. This is the general plan. So with this I have to solve. So I'll take it as T of 0 plus T of n minus 1 plus n. If this is 0, then can I just consider that? I cannot just consider the 0th element. So 0 need not to consider. I'll just write it as T of n is equals to T of n minus 1 plus n. As usual, replace n by n minus 1 because inside the function I have n minus 1. Is it not? Now we'll just start solving this. T of n minus 1. For this function I have to write the entire thing. T of n minus 1 minus 1, that is n minus 2, plus n I have to replace with n minus 1. Yes. So next step, for this function the entire thing, T of n minus 3 plus n minus 1, that is n minus 2, plus this constant as it is, I'll write n minus 1. Yes. Next step, if I take t of n minus 4, this one n minus 1 minus 2 is n minus 3, n minus 1 minus 1 is n minus 2 plus n minus 1. Yes, so this is how, if I'm just keep on writing, it will be t of n minus I. T of n minus I. But here you see n minus 1, n minus 2, n minus 3, n minus 4, like that it will be going. So it will be like 0 plus 1 plus 2 plus 3 till n minus 1. Yes, so this is our standard formula. Yes, this is our standard formula. So this one I can just write it as t of n minus I. This is the progression, arithmetic progression. Yes, so I can write it as n into n plus 1 divided by 2. N into n plus 1 divided by 2. Okay, this is the arithmetic progression. Using arithmetic progression, I'm just writing this one. This is the standard formula for arithmetic progression. Now, you have to replace i's. So, here I have to just get t of 0. Is it not? T of 0 means it will be 1. So, what I'll do? Replace I by what is there inside the function. With this one, I have to replace I. I have just explained this in the previous mathematical analysis videos also. So, replace I by n minus 1. If I replace this I by n minus 1, then what I'll get? T of n minus 1 plus n into n plus 1 divided by 2. So this one will become n and minus n will get cancelled. I'll get t of 1. This one I'll just write it as n into n square divided by 2 plus n into 1, n divided by 2. Yes, if only one element is there, then what is the general form? It is 0 when n is equals to 1. So this t of 1 will become 0. This one I'll just have n square by 2 plus n divided by 2. According to this order of growth, n is the smallest order of growth, n square is the largest order of growth. So among these two, I have to go with this one. This will be like 1 by 2 into n square. So I'll just take n square. So t of n belongs to, this is worst case, that is big O of n square. This is the time complexity for worst case analysis of quicksort. Okay, if any part of the array, either left or right part of the array is empty, then that is considered as worst case efficiency. Okay, now we'll see the average case efficiency of quicksort. So in average case efficiency, for example, I have these many elements. If the pivot element divides the array over here, okay, this is the pivot element, this is the left part of the array, this is the right part of the array. In best case efficiency, you have seen exactly at the middle the pivot element is divided, then both the array will be having equal number of elements. Worst case efficiency, any one part of the array, all the elements will be missing. Either left or right, the elements will be 0. Average case efficiency, this is different than both the cases. If unequal number of elements are present, yes, in both the arrays, left and right, this is not equal. Unequal number of elements are present in left or right part of the array, then that comes under average case efficiency. Okay, so here how many elements will be present? For example, from 0 to n minus 1 elements will be present. Yes, because 1 is the pivot element. So here, if this one, I'm not sure how many elements are there. So this is the pivot element. I'll take pivot element as k. I'll take pivot element as k. Until 0 to k minus 1. Until 0 to k minus 1, this entire thing will be considered as the left part of the array. K is the pivot element. From k plus 1 element, this is right part of the array until n minus 1 elements. This is how the array will be divided in average case efficiency. Yes, so here with respect to our formula, upper bound minus lower bound plus 1. This is the standard formula we have. This is the upper bound. Yes, and this is the lower bound and this is the upper bound. Is it not? So upper bound is what? K minus 1. Lower bound is what? 0 plus 1. Minus 1 and plus 1 will get cancelled. I'll just get it as k. So time required to solve this is t of k. In the same way, I'll just go with the right part of the array. Here also I'll use the same thing. Upper bound minus lower bound plus 1. Which is the upper bound over here? N minus 1. Minus lower bound is what? K plus 1 plus 1. This one. This will get cancelled. I'll get n minus 1 minus k. So time required is what? T of n minus 1 minus k. This is the time required for right part of the array. Yes. So here we have got what is the time required for left part of the array. What is the time required for left part of the right part of the array. Now I have to just write the general plan. T of n summation k is equals to 0 to n minus 1, because we have from 0 to n minus 1. This entire thing I have to take t of k plus t of n minus 1 minus k. Here this is divide and conquer technique, so I'll just write it as 1 divided by n plus the pivot element n plus 1. So by seeing this only, we can see it will just go for longer time, because here we have two different functions. Till now we were having only one function, but here two different functions means it will take longer time to solve. So in this condition, no need to just solve this one. Directly I can just write it as log n to base 2, because while explaining the simple algorithms only, I have just told you if it enters the while loop, then directly we can just write it as log n to base 2. In this case also, if you have two functions, then it is obviously known it will take very longer time, so I can just directly write it as log n to base 2. So here average case efficiency, I can just write it as T of n belongs to theta of log n to base 2. So this is the average case efficiency of quicksort. In all the algorithms, this is not the case. We'll not get best case, worst case and average case efficiency in all the algorithms, only in few algorithms. Among those, this is one of the algorithm where we will get best case, worst case and average case efficiency. All the three efficiencies we need to calculate, because here the array is not, every time the array is not divided at the same position. It can be exactly at the middle, it can be the first element or the last element, or it can be this case, the average case efficiency what I have explained. So in this, all the three cases we will get. Okay, in the next video I'll just come up with the next algorithm of divide and conquer technique. Thank you.